Welcome to video on problem solving exercises. In this video, I will go over optimization technique and we will solve a problem of profit maximization. So let's begin with the given information. We have inverse demand function given as price equal to 60 minus Q. We are also given that the firm has the total cost of producing Q units of output given by Q square. So you can see there is no fixed cost. And for example, if I want to apply this total cost, let's have total cost of 1 unit of output is 1 square. So that's 1. We can compute similarly total cost of 2 units of output 2 square equal to 4 and so on. So we are given the total cost, we are given the inverse demand function. Given the inverse demand function, I can find out the total revenue, which is price times the quantity. Price is 60 minus Q times the quantity multiplied by Q. So I can simplify this expression by multiplying each term in the parenthesis with Q. So I get 60 times Q is 60Q minus Q times Q is Q square. Once I have the total revenue and the total cost, I can write down my profit as total revenue minus total cost. This is 60Q minus Q square, that's the total revenue, minus Q square, that is the total cost. So my profit turns out to be 60Q and I have two terms, Q square twice, so minus 2Q square. This is the object which we want to maximize. So my profit maximization exercise I can write now as maximize profit, which is a function of Q, to be equal to 60Q minus 2Q square. And we can see our choice variable Q, which we expect it to be positive. I will write it as non-negative. So let me formally state the objective function. The objective function for my profit maximization exercise is the profit 60Q minus 2Q square. The choice variable, the object we want to keep changing to find out the maximum possible value, Q to be positive. I have written it as non-negative, but let me make it positive because this is what we expect. And then, so I want to apply the calculus technique of finding first order conditions. So I will state it. If the profit is maximized at some quantity Q star positive, then at Q star the first order condition, I will write FOC, must hold. So let's apply this. The derivative of the profit with respect to Q, I'll call it as first order condition, turns out to be, I have 6, let me write it, the expression itself, derivative of 60Q minus 2Q square turns out to be derivative of 60q is 60 minus 2 times derivative of q square is 2 q to the power 2 minus 1, and this needs to be equal to 0. So let me simplify this further. 60 minus 4, 2 times 2 is 4, q to the power 2 minus 1, q to the power 1, but we don't write power 1. So I got 60 minus 4q to be equal to 0, and then I can simplify. This is one equation, one unknown. I can take this negative 4q to the right hand side, will become positive. I divide both sides by 4, and then I get q to be equal to 15. 60 over 4 is 15. I want to say this is the unique solution I got. This must be maximizing the profit. I put a star here. Once I know Q star, I'll find out the total revenue for which I need the price. So price is 60 minus Q, 60 minus 15, $45. So I'll call this P star. So I have the quantity, I have the price, total revenue is price times the quantity. P star times Q star, 45 times 15 turns out to be 675. We can use calculator to find this answer. And then the total cost, if we recall, is Q star. So I have output to be 15. I square it, I get 225. The difference of these two is the profit. Total revenue minus total cost, 675 minus 225 turns out to be 450. So now we have got the solution. Q star 15, P star 45, and the maximum profit $450. And that's a good point to stop.